Hey everybody, this is Larry. This is day 11, if it ever loads. Does it load? Anyway, alright, that page loads. Day 11 of the Leetcode Day Challenge. Hit the like button, subscribe, and join me on Discord. Let me know what you think about today's problem. Yeah. Journey. Basically right now I'm in between, taking a little bit of rest because I desperately needed. My energy was really off, as you know. Yeah, just doing a little bit of chat. And I think for me, it's just about trying to figure out what my next goals are. The marathon training, especially the last month or two or something like this, it's a huge sacrifice, right? Like I was skipping on a lot of things to make the marathon work. It just takes a lot of time, just both training and recovery and eating and all these things. And even aside from that, I'm just tired all the time. And honestly, I find myself like a little bit more irritable. Like I was just annoyed at everything, quite frankly, right? So it's a huge sacrifice. I mean, and right now I'm not training for another one, so I'm just trying to see, just trying to figure out what I want, right? And so that's basically the idea with what I'm doing, which for now I haven't really decided yet. Still trying to see where my body is at. I ran a quick mile or so today, or 1K. It was not, I don't know, not in good shape. Wasn't able to do the 6 minute mile, so a little bit slow. But I did squat yesterday. Also, the squat didn't go well either. I only squatted a little bit about my body weight, but I think I have to figure things out. I probably mentioned this in my video like a couple of months ago, but I injured my groin a little bit from I don't even know where or when, honestly, anymore. But in any case, when I was trying to go for a squat the other day, I felt that I was like, oh yeah, I do remember I have to get this fixed, so I might have to talk to a physical therapist and get some exercise on. The reason why it wasn't urgent is because it doesn't affect my running, because running, especially at a marathon pace, running at a marathon pace for a marathon distance for 26 miles, you're not going at your full speed and full strength for 26 miles because, well, by definition almost, right? Like if you can, then that's not your full strength, right? For the most part, I mean, some people maybe build a little bit differently, but so yeah, so it only happens when I run at like much faster speeds and when I do squats. So that's why I was able to put it on hold. But now I'm like, oh yeah, I forgot I have to deal with this. So I have to deal with it. So that's really the first thing I would talk about, and we'll see where I go. I know that a lot of y'all kind of been you like my journey and talking about it. Let me know in the comments if it gets a little bit too much, too boring, or whatever. I mean, I don't know. I still might talk about it, but at least I'll have some feedback, right? But yeah, the reason why I talk about these goals is that I also kind of bring it back to Leetcode, right? I mean, I some part of it. I mean, of course, maybe some of you just wants to like see the problem solved, but I think like for me, there are a lot of analogies and similarities, right? And for me, it's kind of fun to kind of talk about things that I'm struggling with right now with respect to physical fitness, and hopefully kind of relate to other people's Leetcode struggles in a way, right? Like that's, I mean, it's not why I do it, but I think it's a very good parallel because, and to be frank, right now Leetcode is easy-ish for me, and I don't say that to brag, but it's just that every struggle you've been through with Leetcode, I've done it before, right? Maybe on competitive programming and in other ways, but similar probably, right? Like I did not, I think there's a lot of conversation that people talk about, especially when you're younger, when I was younger, that I kind of wish I had more talent, wish I was smarter, etc., right? But But that's not the bar, right? Like if you're trying to be, the top five in the world at something, well, you're right. You definitely need a little bit of luck. You need a little bit of talent. You need a little bit of a head start and all these things, right? But for the most part, you just want to be confident. Just want to be good. You want to be good enough for a job interview. I think like most people should be able to at least get the fundamentals down. There are other parts of the job interview, and there are also just luck with a job interview. But at least the Leetcode bar, I think most people should be able to do, right? And I kind of bring that parallel to me and running because, like, and some of it takes dedication, right? But some speeds people should be able to do. I would also say that, as long as you kind of take your time and pace and know what the training takes, right? Because I did a sub 4 marathon, but it wasn't, and it was from nothing, but it was way hard work, right? Like I mean, you could watch some of those video backs, just watch the beginnings, and I kind of talk about running every day pretty much for like 2 months, right? But even on Leetcode, I definitely have struggled just like you did at some points in my career, right? But it's just that I've done so many problems now, and I think I don't bring it up enough, but I probably have done like, I don't know, 10,000 problems, maybe more. I don't even know how to count anymore. I mean, even on Leetcode, I've done like 2,500 or something like this. I don't even know anymore, right? But and then you just add up like all the other platforms where I've done thousands as well. It adds up, and sometimes resolving old problems which I've forgotten. So maybe you could count that. I don't know if you count that as new. And of course, maybe I'm not getting super better on the high end, right? Because I'm not working on problems that are like code force red level or something to get better at that. But that's fine for me because I'm not trying to get better. Like for me, there's no value in it. Or like not or the cost is high, right? It's like training for the marathon again. Like, okay, and then what? You're just gonna go around telling people that you're red or telling people that I want a sub 4 marathon, right? But in the same way with running, I got to a point where I consider myself, relatively fit, relatively okay, and that's good enough for me. Just like in Leetcode, I'm relatively okay. I don't like, if I and I'm, it's fun for me to do, and I do learn from time to time, but I'm not going to like, push too hard because the cost at a certain point gets way harder, right? And anyway, but people ask me why I talk about running so much is because I think there's a lot of parallels, and that's, I just want to share that part of the struggle. But one thing I would say is that every silly mistake that you've made on, like, you spent 2 hours debugging a little typo. Listen, I've done that many times. I probably did it like 2 weeks ago, stuff like that, right? So everyone goes through it. It is not how fast or how quickly you're able to solve these things that determines who you are. It is when you stop running, it is when you stop trying, it is when you stop grinding, right? When you keep going, you'll keep getting to places. That's really it. Okay, so that's all I have for the chat. One thing that I would also kind of like to spam a little bit, that I don't make money off this, and I don't even try because I don't know. If I wanted to make money, I just get a job, right? But in any case, but I do take pride in my photography and Instagram, so definitely check out my Instagram page. This is my recent photo that I took in. This one is in Almaty in Kazakhstan, and it's just, I don't know, one of my favorite photos. So definitely check or hit a like button or whatever, and let me know how that goes. But but that's pretty much the pre-talk. Let's take a look at this problem and let's get to some solving. Today we have 2601 prime subtraction operation. Okay, so you're given a 0 index integer array nums of length n. You can perform the following operation as many times as you want. Pick an index I that you haven't picked before and pick the prime p strictly less than num sub I, and then subtract p from num sub I. Return true if you can make nums a strictly increasing array using the above operation and false otherwise. A strictly increasing array is a subarray whose each element is strictly greater than its preceding element. Okay. Let's see. Pick a prime p and then subtract p from it. Okay, and so first thing to notice is that the bounds are less than 1,000. So what that really means is that you can, well, you know the primes that are less than 1,000 pretty easily, so we can do that, right? So you don't have to worry about crazy prime algorithms, is what I'm trying to say here, right? The way that I would think about it is initially, n is 1,000 is a little bit tricky. I think the way that I would initially think about is there a greedy algorithm? Is there a greedy way to solve this, right? And if there is, well, the thing that is that we want a strictly increasing array, right? So what does that mean? That means that for me anyway, going from right to left, right? And the reason why I go from right to left in this particular one is that because going from right to left, going from bigger to smaller, and we're trying to keep it strictly increasing. Well, the thing is that for this problem, we can only subtract, right? And because we can only subtract, all the numbers can only go smaller. So what this means is that, for example, if we have an array like this, maybe, yeah. And then now, okay, 6 and 10 is, oops, 6 and 10 is good, but then now you see a 9, which is bigger than 6, right? Well, the thing is that at this point, you know that, well, the 10 doesn't matter because 9 is still bigger than 6. So we only care about the 9 and the 6 in this instant, going from right to left. So we always skip the 6 and the 10 because it was already good. But we only can do one thing, right, really? We can only do one thing because, well, you can only subtract, so there's only one choice. So we have to subtract from the 9. You can't, or I mean, you can subtract from the 6, but it doesn't do anything. It will only make it worse, right? So that means that you want to subtract the 9. And then now, in a greedy way, you ask, well, what can we do with this, right? Well, you probably want to subtract the smallest number so that it is the biggest number, right? And this part is greedy because you want the 9 or the index 1, 0 index, so the index that 9 is in, you want that number to be as big as possible but still smaller than 6, right? Because in that way, then you allow more numbers from the left to keep going. And that's really the idea that I would have, and I think that's good enough for me to get started. So let's yeah, let's start getting let's start playing with this, is what I mean to say. Yeah, so then now we have for I in range of, we go backwards. Yeah, I mean, I think that's really it, right? And we never, well, the last element is important, but we never really, you would never subtract from the last element, right? For the same logic, because it can only make the problem more annoying. So then now, so if num sub I is greater than num sub I minus 1, then now, I plus 1, whoops. Then now we're trying, make num sub I the biggest number that is smaller than num sub I plus 1, right? And here, you know, I think the idea is probably binary search. And what I mean by that is that you have a list of primes, you binary search the number that will give you the biggest number. I mean, you could probably solve for this. Hang on, let me drink some tea. And I would say that you don't have to binary search because n is 1,000 and all the numbers are 1,000. So in theory, you can be very easy with 1,000 squared by just trying every number and seeing the difference is prime. But basically now you're saying that, okay, so num sub I minus some p is going to be less than num sub I plus 1, right? So this is your formula. This is not code, sorry. Right? This is the formula that we're looking to manipulate, right? We know what most of these numbers are, right? Like these are, we know what this is, so then we can subtract this on this side, right? So now you have num sub I minus this, you add p on both sides, so you have this less than this, right? And then now if you have a p array, then we just p being all the primes, p being all the primes, you can binary search on it, right? So that's really the idea behind this particular part, and that should be good. So that means that we just need to set up primes, right? So primes is equal to, I don't know, 2, right? How do I want to do it? There's so many ways to write primes that I'm just a little bit lazy. I mean, you certainly, yeah. I mean, let's just do it with the normal SIF, right? So first times, maybe max of the number. Yeah, maybe that's fine. I mean, you can definitely do whatever, right? Like, I don't know. I mean, this is a little bit of overkill in either case, but if you do want to Google search it up, it's called the SIF of, I always spelled this incorrectly. Let me Google it. Ah, so close. Extra something. Extra S, I think. Is that right? Is this right? Yeah, okay. Yeah, so definitely Google for this, and yeah. Oops, and I already screwed it up, but yeah, for I range from 2 to max plus 1. Oh no, I guess we don't need max plus 1, we just do max, so I did the plus 1 up there. But yeah, yeah, okay. Right, and then now if primes of I, then we just do j is equal to I times I, while j is technically you could do like I times 2 or something like this, but whatever. So this is a general SIF. I'm not going to go over the complexity or whatever real quickly, but this is going to be mx log m. But now you have this prime array, which you can just, I mean, you could definitely write this another way, but yeah. So then and then now if it's prime, then we just write, I don't know, just a p array of p append I. So then now you should have all the primes, right? Up to whatever. I don't know, just return, whatever. It's just so that I can run the code and make sure that this part prints correctly. And okay, for up to 10 it goes 2, 3, 5, 7, right? Oh, I usually write it this way, but it's a little bit awkward, I suppose. I don't know. But yeah, you can see that these are all primes before, whatever, right? So that's good. And then now we're trying to binary search for p, given this number, right? Yeah, so we're trying to find, we'll always have to, maybe you could do like an inverse find thing, but I think like we do a bisect left. If it's exactly this number, then you want that index, so then you could go to the previous one, right? So then this is the index, right? And then the previous one is going to be, so this bisect left gives you something that's greater than or equal to p, or equal to this number. So I don't know. So then the previous one to that would be the smaller one. So then now index -1 is well in the array. Then that is the p that we care about, and we just keep going, right? Else we just return false, because that means that we cannot find a number to subtract that is enough. Do they have to be positive? I don't. Doesn't seem like we have to, but I don't know. Right, and that's pretty much it. I think. I think if you're a little bit not convinced, then you can assert that num sub I is greater or less than num sub I plus 1, just to kind of see if it works. Hopefully it does, but apparently it doesn't. Dong dong dong. So we minus 2y. So you have 9 and 6. So we binary search for 9 and 6. We have 3. Did I mess up the direction? So that's Leetcode 2. So do we want the next number because we want to subtract? Okay, so it's exactly the same. So maybe I got the direction wrong. So which happens a lot. So if it's exactly the same, then this would be not good because it's just right. So then we want the next number. Oh yeah, because we don't want the number that's slightly smaller. we want the prime that is bigger, which is in the formula that I apparently deleted actually. So I messed this up, my fault. But in this case, this is exactly index. But then now we can check that this is in length of p, I suppose. Then yeah, But this is why you have a search, so then it catches stuff like this. And okay, so it doesn't look too good, but yeah, why is this forced? I mean, this is a little bit awkward, I think, because I think does it say anything about positive? Maybe it does, and I didn't. Because yeah, oh wait. Oh, it has to be less than the number. Okay, I missed about that, because then, yeah, the reason is because then now you get it to 0, right? And so then there are a couple of ways to think about this. I mean, you can just, in that case, assert that, or if num sub 0 is greater than, or if less than or equal to 0, we return false. The reason being that it's going, if it happened not on the first element, it would happen in the middle element, but that cascades down, right? Because to keep it strictly less than. So okay. So I think this should fix it, but we'll see. Let's give a quick submit. Oh no! Oh. So you search. This is bisect, right? It should be 3, right? Why is this? Dong dong dong. Yep. Oh, because this is Leetcode too. No, okay. I just messed up on the sign. I was, because it has to be strictly greater than. So yeah, I that was just again a little bit sloppy on the if statement. So that's why. Okay, so we were actually mostly pretty good, honestly. Just a little bit of silly mistakes. I mean, this one is off by 1, classic. What did I do last time? I think I just did the n square last time. I think n square is. Yeah, so I did the n square last time, which is much easier, honestly, right? Because you don't have to worry about off by 1s and stuff like this. I mean, you still kind of do, but it is easier to show. And I even did a final loop here. But yeah, but this time we tried to be a little bit better with the n log m b, where b is the maximum digit or something like this, or m, where m is number of primes under that number, which is okay. So maybe it's a little bit better and it's a lot faster, but definitely slightly more error prone, especially when you're a little bit silly like me. But anyway, that is all I have for this one. Let me know what you think. Thanks for watching, and yeah, you could watch me solve it live. Wait, what? No, that's different. I don't know. I'm still a little bit off. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.